Hello and welcome back to BlueHatCyberSec Academy. In this video, we will explore further topics from Domain 3 of the Certified in Cybersecurity exam, which is about access control concepts. This video isn't just for exam preparation, it's also perfect for anyone interested in building a strong foundation in the world of cybersecurity. We are going to discuss in this lesson, Number 1, Logical Access Controls. Number 2, Discretionary Access Control, or DAC. Number 3, Mandatory Access Control, MAC. Then number 4, Role-Based Access Control, or RBAC. Make sure to watch till the end because these topics are the foundations of cybersecurity. If you haven't already, subscribe to BlueHatCyberSec Academy. Your path to becoming a cybersecurity professional starts right here. What are logical access controls? While physical access controls are tangible mechanisms that limit someone from entering a physical area or accessing a physical asset, logical access controls are electronic methods that restrict access to systems, and in some cases, even to tangible assets or areas. Types of logical access controls include media, hands typing password, into login field on monitor, password input screen on digital device passwords, biometrics implemented on a system such as a smartphone or laptop, and badge or token readers connected to a system. These electronic tools determine who can gain logical access to an asset, even if the person already has physical access. Now that we've understood what logical access controls are, let's move further and discuss specific types of access control models, starting with discretionary access control, or DAC. Discretionary access control is a specific type of access control policy that applies to all subjects and objects within an information system. In DAC, the policy specifies that a subject who has been granted access to information can do one or more of the following: pass the information to other subjects or objects, grant its privileges to other subjects, change security attributes on subjects, objects, information systems, or components, choose security attributes to associate with newly created or revised objects, and change the rules governing access control. Note that mandatory access control restricts this capability. For example, discretionary access control systems allow users to set or change permissions on files they create or own. Let's say Steve and Aiden are two users in a Unix environment operating under DAC. Typically, systems maintain a table that maps subjects to objects. At each intersection lies a set of permissions that a specific subject has for a particular object. Many operating systems, such as Windows, Linux, Unix, and iOS, use this type of data structure to make quick and accurate authorization decisions. This data can be viewed in two ways. An Objects Access Control List, or ACL, shows all subjects with any permissions for that object, and a Subjects Capabilities List shows all objects that the subject has permission to access. This methodology depends on the discretion of the owner of the object to determine specific access rights. Hence, the security of the object is literally up to the owner's discretion. However, DACs are not very scalable because they rely on individual object owners' access control decisions. This can make it difficult to trace or manage access issues when they occur. Most information systems operate using discretionary access control, or DAC. In these systems, a user who has access to a file can, share or transfer that file to someone else. It's really up to the asset owner to decide whether to grant or revoke access. For computer files, this is often handled through shared file permissions or maybe password protection. For example, when you create a file in an online sharing platform, you have the discretion to restrict who views it. DAC can also work in simple ways, like issuing a visitor badge at a security desk, based on the employee's discretion. Now that we've explored discretionary access control, let's move on to another method that's a bit more rigid and policy-driven, which is called Mandatory Access Control, or MAC. A mandatory access control policy is enforced uniformly across all subjects and objects within an information system. Basically, Only properly designated security administrators, who are considered trusted subjects, can modify or define the security rules that govern subjects and objects in the system. This means that for everyone defined by the organization itself assigns a limited set of privileges for specific objects. As a result, the subject is restricted from passing information to unauthorized people or objects, granting their privileges to others, changing any security attributes on subjects, objects, or system components, choosing security attributes for new or modified objects, or changing the rules that govern access control. Although MAC might sound a lot like DAC, the key difference is in who controls access. In MAC, security administrators assign access rights and permissions, while in DAC, it's left up to the object owner. Now that we know what MAC is, let's see how this system functions in real-world organizational settings. In workplace environments, mandatory access control is enforced by the asset owner on an organization-wide basis, so there's really not much room for individual decision-making. For example, in certain government agencies, personnel must have a specific level of security clearance to access certain areas. This level of access is defined by government policy, not by individual judgment. Often this is accompanied by separation of duties, where the scope of work is limited and users do not have access to information that does not concern them. This separation of duties is also facilitated by role-based access control. Now, let's move ahead and discuss that next. Role-based access control, RBAC. A role is created and assigned the access required for personnel working in that role. When a user takes on a job, the administrator assigns them to the appropriate role. If a user leaves that role, the administrator removes that user, and access associated with that role is removed. Each works well in an environment with high staff turnover and multiple personnel with similar access requirements. Now that we've defined RBAC, let's see how it is practically implemented in workplaces. Role-based access control provides each worker privileges based on what role they have in the organization. Only human resources has access to personnel files, for example. Only finance has access to bank accounts. Each manager has access to their own direct reports and their own department. Very high-level system administrators may have access to everything, while new employees would have very limited access. The minimum required to do their jobs. Monitoring these role-based permissions is important, because if one person's permissions are expanded for a specific reason, say, a junior worker's permissions might be expanded so they can temporarily act as the department manager, but their permissions aren't changed back when the new manager is hired, then the next person to come in at that junior level might inherit those permissions when it is not appropriate for them to have them. This is called privilege creep or permissions creep. Having multiple roles with different combinations of permissions can require close monitoring to make sure everyone has the access they need to do their jobs, and nothing more. In this world where jobs are ever-changing, this can sometimes be a challenge to keep track of, especially with extremely granular roles and permissions. Upon hiring or changing roles, a best practice is to not copy user profiles to new users. It is recommended that standard roles are established, and new users are created based on those standards rather than an actual user. That way, new employees start with the appropriate roles and permissions. That's all for this session. It is the last video of Domain 3 topics included in Certified in Cybersecurity, CC Exam by ISC2. We will continue this series in the next video and start Domain 4, which is about network security. Continue your learning journey. And if you found this helpful, don't forget to like, share, and subscribe to BlueHatCyberSec Academy for more cybersecurity insights and complete course content.